Welcome to this step-by-step guide to systematic AI development using RooCode. If your team is currently using AI tools randomly, copying code from ChatGPT, accepting whatever Copilot suggests, getting inconsistent results, this presentation will show you how to transform that chaos into a predictable, professional workflow. I'm going to walk you through a complete task from our actual project, showing you the exact process we use to go from random AI usage to systematic development that produces maintainable code your team actually understands. This isn't theoretical. Everything you'll see comes from real implementation with real challenges. The key insight is this: AI doesn't write code, developers write code. Whether you're using traditional tools or AI assistants, you are making the decisions, you are reviewing the output, and you are responsible for what goes into production. The systematic approach ensures you maintain control while leveraging AI's strengths effectively. We know from previous presentations that random AI usage leads to technical debt and maintenance nightmares. The systematic approach centers on two key concepts: triple gate control and a three-mode system that separates thinking from building. Triple gate control ensures quality at every step. Gate 1 is AI self-verification, automated checking for basic technical issues. Gate 2 is mandatory human verification. You personally test the implementation and confirm it works. Gate 3 is understanding validation. You must be able to explain the key decisions and architectural choices. The three-mode system prevents design while coding chaos. Task coordinator handles project setup and task generation from your documentation. Task architect creates detailed plans without writing any code. Pure thinking phase. Systematic developer implements those plans with strict verification requirements. This separation is crucial. When you try to design and code simultaneously, you make architectural decisions under implementation pressure, leading to shortcuts and technical debt. The systematic approach ensures thoughtful design happens before implementation begins. Everything starts with proper documentation. Your PM team provides project purpose, acceptance criteria, user scenarios, and data model. Your tech team provides tech stack decisions and developer guidelines. This isn't busy work. This becomes the context that enables AI to generate code that fits your specific requirements instead of generic solutions. The file organization is equally important. Active task contains only current work, preventing RooCode from overwriting your progress files. Completed tasks preserves learning with numbered archives. This structure ensures clean handoffs and maintains project history. The key insight is that AI needs complete context, not random prompting. When you provide comprehensive requirements, AI can generate professional solutions. When you provide fragments, AI resorts to guessing and produces generic code that requires extensive manual translation. For complete setup instructions, refer to the RooCode Systematic Setup guide attached to this video. It contains everything you need: directory structure creation commands, the complete custom modes JSON configuration, all the rules, files, and templates, and step-by-step installation instructions. The key insight from the setup is the file organization. Active task contains only current work, preventing RooCode from overriding your progress. Completed tasks preserves learning with numbered archives. Roo folder contains rules that guide AI behavior, and docs planning holds your project-wide documentation. This structure isn't arbitrary. It's designed to prevent common RooCode problems and ensure systematic workflow enforcement. Let me show you Task Coordinator in action using our real Task 8 Frontend dashboard implementation. The coordinator analyzed our project documentation and generated a comprehensive task definition. Look at the specificity. It identified core dashboard components, AP integration requirements, and clear deliverables. This isn't generic build a dashboard. It's a complete specification derived from our actual project needs. The coordinator understood that we needed metrics display, constituency overview, activity visualization, and proper TypeScript integration. It generated acceptance criteria that align with our business requirements. The result is a clear, actionable task that provides complete context for the next phase. Task Architect will use this specification to create detailed implementation plans without having to guess requirements or make assumptions about project scope. Task Architect took the coordinator's task definition and created detailed implementation plans. Look at the file structure. It's not just a list of files. It's a complete component hierarchy showing relationships and dependencies. Dashboard components, metrics components, constituency components, all properly organized. The architect also created interfaces defining exact TypeScript types, implementation plans with step-by-step phases, and architecture decisions with clear rationale. Critically, no implementation code was written. This is pure planning phase. This separation prevents design, while coding problems. When you're writing code, you're under pressure to get something working quickly. When you're planning, you can think through the architecture carefully and make better decisions. The systematic approach enforces this separation to prevent technical debt. Systematic Developer received complete architectural plans and implemented the dashboard components. Look at this metrics summary component. Clean TypeScript interfaces, proper error handling, loading states, responsive design. This isn't generic AI code. It's professional implementation following detailed specifications. The code integrates seamlessly with our existing design system, follows our established patterns, and handles edge cases appropriately. Why? Because it wasn't generated from vague prompts. It was implemented from comprehensive specifications created during the planning phase. But here's the critical part. Systematic Developer must follow triple gate verification. It can't just generate code and move on. Every implementation goes through structured verification that ensures both functionality and understanding. Now let me show you what actually happened during Gate 2 verification. This is where theory meets reality. RooCode finished implementing the dashboard and said task complete. But when I tested manually, the election filter didn't change the displayed data. This started a debugging cycle that took 4 iterations to resolve. First, I found that setSelectedElection wasn't triggering data fetches. RooCode fixed that, but the problem persisted. Then I discovered the mock AP wasn't responding to filter parameters. RooCode updated the API layer, but there were still issues with state management. The point isn't that AI failed. The point is that manual testing caught real issues that automated checks missed. Gate 2. Verification isn't bureaucracy. It's professional development practice that prevents shipping broken features. Let me show you the specific fix from Task 8. The original setSelectedElection function just updated state without triggering new data fetches. Users could change elections, but the dashboard would show stale data from the previous selection. The fix added automatic data fetching when elections change, but it required understanding the asynchronous flow and state management patterns. This is exactly why Gate 3 understanding validation matters. If you don't understand the implementation, you can't maintain or extend it effectively. The systematic approach made these fixes manageable because we had clear specifications and verification processes. Problems became predictable engineering challenges rather than mysterious failures. Gate 3. Understanding validation uses quiz questions to ensure knowledge transfer. Here are real examples from Task 8. Explain the key technical decisions made in the dashboard implementation and why. Why? This ensures you understand the architectural choices, not just that the code works. What would happen if a user rapidly switches between different elections? This tests understanding of edge cases and error handling. How would you modify this implementation to support real-time updates? This verifies you can extend the code for future requirements. The requirement is 80% understanding to proceed. If you can't explain the key decisions, you don't control the code. This prevents the accumulation of AI-generated code that nobody on the team understands, a recipe for maintenance nightmares. Here's what we achieved in about 30 minutes of systematic development. Production-ready dashboard components that match our Figma designs exactly. Complete TypeScript integration with proper error handling. Responsive design that works on mobile devices. Comprehensive state management with proper loading states. But more importantly, we have understanding to maintain and extend this code. The systematic approach didn't just produce working software. It ensured knowledge transfer so the team can evolve the implementation as requirements change. This is the difference between random AI usage and systematic development. Random usage produces code you don't understand. Systematic development produces solutions you can maintain and extend professionally. Your team will encounter predictable issues with RooCode. Problem 1. RooCode tries to end tasks early with green task, complete messages. Ignore these and use your verification checklist instead. RooCode is optimized for conversation completion, not systematic development. Problem 2. Context loss during long conversations. RooCode will summarize previous context, and important details get lost. The solution isn't to restart the conversation, but to recognize when critical details have been lost and compensate accordingly. Require context even for current documentation. Mention your data model file again, or explicitly reference key architectural decisions that may have been summarized away. Problem 3. RooCode forgets about triple gate verification. It will generate code and try to move on without proper verification. Remind it manually to generate verification documentation and follow your quality gates. These aren't failures, they're predictable behaviors that you manage through systematic oversight. Understanding these patterns helps you guide RooCode effectively rather than fighting against its natural tendencies. Expect the intervention pattern I showed in Task 8. RooCode says, implementation is complete. You test manually and find issues. RooCode fixes the specific problem. You test again and find more issues. Iterate until everything works correctly. This isn't a bug in the process. It's a feature. The systematic approach focuses AI on what it does best, mechanical implementation of detailed specifications, while keeping humans responsible for quality verification and architectural decisions. Your role is to guide AI back on track when it deviates from systematic practices. This is normal and necessary for professional development. Teams that skip human oversight end up with technical debt that costs far more than the time saved during initial development. One major challenge is AI knowledge gaps around current APIs. LMS default to older syntax from their training data. For example, They'll use Tailwind 3 syntax when you're using Tailwind 4, or suggest deprecated React patterns. Context-Even XCP provides current documentation to AI tools, ensuring they use latest APIs instead of outdated training data. Set up Context-Even, connect it to your current documentation, and AI will generate code using your actual technology stack instead of generic patterns. This is crucial for TypeScript projects where API changes frequently. Without current context, AI generates code that compiles but uses outdated patterns. With Context-Even, AI stays current with your technology choices. The daily workflow follows a predictable pattern. Task Coordinator analyzes your project documentation and generates the next logical task. Task Architect creates complete implementation plans with interfaces and file structures. Systematic Developer follows those plans with triple-gate verification. When tasks complete, you archive them with sequential numbering and move to the next iteration. This creates a clear development history and prevents work from being lost or overwritten. The key is maintaining discipline around the mode transitions. Don't skip planning phases, don't skip verification gates, and don't let RooCode deviate from systematic practices. Consistency in process leads to consistency in results. You'll know the system is working when RooCode generates detailed, logical development roadmaps like this one. Foundation tasks that other work depends on, feature tasks built on that foundation, integration tasks that bring everything together. Good indicators include detailed task breakdowns, logical sequencing with clear dependencies, specific deliverables with acceptance criteria, and realistic time estimate. Poor indicators include vague descriptions, no dependencies identified, generic deliverables, and unrealistic scope. The systematic approach trains AI to think architecturally about development rather than just generating code fragments. This leads to better project organization and more maintainable results. For team implementation, start with Foundation Setup. Part 2. Install RooCode, configure custom modes, set up directory structure, and train the team on triple-gate verification. Practice with one simple task to build confidence and identify issues. Phase 2 focuses on adoption. Use the systematic approach for all new features. Document what works and what doesn't. Refine verification processes based on results, and build team habits around quality gates. This phase requires discipline as the team adjusts to new practices. Phase 3 enables scaling. Customize rules for your specific technology stack. Create project-specific documentation. Templates, train new team members on systematic approaches, and continuously improve the process based on experience. The key is gradual adoption with consistent application. Don't try to implement everything at once. Build systematic habits progressively and refine based on what works for your specific context. Start tomorrow with one simple task from your current project. Use the 3-mode workflow we demonstrated. Apply triple-gate verification to ensure both functionality and understanding, and document what works and what breaks for your specific context. Build systematically by setting up proper documentation first, training your team on verification habits, focusing on understanding rather than just working code, and iterating based on results. Remember that tools will evolve and change, but the systematic approach of proper preparation, structured documentation, and quality verification will remain essential. The goal isn't perfect AI assistance on day one. It's building sustainable development practices that improve code quality while maintaining human oversight and understanding. Master the systematic principles, and you'll adapt successfully to any AI tools that emerge. Thanks for watching this step-by-step guide to systematic AI development with RooCode. This presentation was created using the systematic AI-assisted development principles we demonstrated. It's not just theory, it's proven practice that works with demanding timelines and quality requirements. Subscribe if you want practical AI development workflows that focus on systematic results rather than hype and promises.